How did the universe begin? What is its source? Few questions have generated as much controversy through the centuries or inspired as many impassioned opinions. I interviewed William Lane Craig, a philosopher who has devoted much of his career to the study of cosmology and the question of origins.
From ancient Greek materialism at the time of Plato and Aristotle up through 19th century idealism, the prevailing view was that the universe is eternal, that the universe never began to exist, that the universe as a whole is, as it were, a static, timeless entity.
This belief in an eternal, unchanging universe, for centuries a pillar of Western cosmology, was unexpectedly challenged in 1915 by Albert Einstein's general theory of relativity. Einstein's equations implied a startling possibility. The cosmos was not static, but instead existed in a continual state of either contraction or expansion.
Einstein did not like the idea that the universe was dynamic at all. In fact, like almost all scientists at the time in the early 20th century, he assumed the universe was static and eternal. What's interesting and ironic is that he thought he had made some kind of mistake in his equations for the general theory of relativity. But a few years after he developed the theory, a Belgian astronomer named Lemaitre developed a model based upon his equations, which again predicted that the universe was in a continual state of expansion.
In 1929, theoretical predictions were confirmed with empirical data. At the Mount Wilson Observatory overlooking Los Angeles, astronomer Edwin Hubble studied light from distant galaxies. Hubble determined that galaxies beyond our Milky Way were moving away from us at a speed proportional to their distance from the Earth. The more distant the galaxy, the faster it is receding. Hubble's landmark discovery led most astronomers and physicists, including Albert Einstein, to a similar conclusion. If the universe is continually expanding, then at earlier points in its history, it must have been smaller and denser.
I think a good way to visualize this is to imagine that the history of the universe has somehow been photographed and made into a movie that we could play on a projector. As the projector runs forward, we watch the universe as it continually expands. But if the projector were to be stopped and were switched into reverse to make the movie run backward, then instead of watching the galaxies move farther and farther apart from each other, we'd see them draw closer and closer together.
As you trace this expansion back in time, the universe grows denser and denser and denser until finally the entire known universe is contracted down to a state of infinite density, which marked the beginning of the universe. At this point, which cosmologists call the singularity, all matter and energy, physical space and time themselves came into being. This literally represents the origin of the universe from nothing. So the startling implication of Hubble's discovery was the temporal finitude of the universe, that the universe had an absolute beginning at some point in the finite past.